David Jenkins and the organizers for inviting me to speak here. In some respects, I think I'm going to be, you know well, I'm going to be raining on your party to some extent. And, but I just want to say I'm also happy to be here and participate in anything with David Jenkins. I have a huge admiration and respect for everything that you've done, David, from way back when I started following the field. Must be 35 plus years ago. So, okay, so let's sort of ease into this issue of glycemic index and health outcomes by just reviewing the kinds of evidence we have to deal with. Well, they're controlled dietary trials with cardiovascular disease and diabetes. That's what we're talking about here, ultimately. And those outcome trials should be characterized, all of them really, as effectiveness trials. Because they require years of duration. But they do provide the potential for definitive evidence. And examples of that would be, for example, DPP in the diabetes field or Prediabetic in the cardiovascular field. So, but they also have a potential for disaster due to poor adherence. And I'm not going to name any names of those studies, but those are hotly debated, and everybody here, I think, has in mind a study that you might think was a disaster. So to be very careful, they're very expensive studies and difficult to carry out and understand. And when there is a disaster, there's rampant misunderstanding, debate, controversy. It's a very messy, unpleasant affair in that situation. So these trials that have true disease outcomes are rare in the nutrition field for a whole lot of reasons. Now, the other type of diet trials that we see much more of are diet trials that have outcomes as mediators or as mechanisms. For example, and so there are different types of these, and one type is when complete diets are given. Now they, by necessity, have to be short duration, weeks or a few months at the most. They're pure efficacy. In other words, the diet is totally controlled. There's no issue really of adherence or behavioral teaching or whatever. They're great in that regard. They're short duration, and they can deliver definitive results with limitations. Limitations meaning the boundaries of their study design itself. Okay, they're bounded. The validity is bounded by the study design, but within that design, they can give definitive evidence. Now, the other type of such trial is behavioral and diet instruction. They can be longer duration, and I call them pure effectiveness because really they depend a lot. I mean, the results can be dominated by adherence, not necessarily by the biology of the intervention. Now then, we have a totally different kind of research, the observational epidemiology, and that can look directly at cardiovascular disease and diabetes. I have a great respect for observational epidemiology, even though I'm mostly a trialist. The fact is that we can make strong conclusions when these two types of studies produce consistent results, because we rarely have that first type of study, like Prediabetic or DPP with a direct disease outcome. So we've got the observational studies, long duration. They have their own limitations because they're not controlled trials. And then we have the trials that look at mediators that will really provide the causal link. Okay, so now let me review very briefly, one slide only, on carbohydrate amount. I feel that carbohydrate amount, it's pretty much settled scientific knowledge at this point, what reducing total carbohydrate does. Well, it decreases blood triglyceride, and that's a major effect. And you'll see in the OmniCarb study, that was the major effect that we found, is reducing triglycerides with reducing total carbohydrate. Now, Mendelian genetics is entered into this controversy about whether triglyceride is a causal factor or not, and firmly sits on the side that triglyceride is a causal factor. It's not simply some marker. And it could be essentially a marker of, well, it could be a marker, but a marker of something causal, such as apolipoprotein C3. So it could be something atherogenic like that. But it's very important. So anything that's decreasing triglycerides should be kept in mind as potentially causal with the disease outcome. It increases HDL cholesterol, but that we really have trouble interpreting these days. Now, lowering carbohydrate amount will decrease or increase LDL cholesterol depending on the type of fat to replace it. Meaning, polyunsaturated fat will decrease, LDL cholesterol saturated will increase, or trans will increase. It decreases blood pressure, a small effect, decreases blood glucose and glycation of proteins. And in my view, there's no clear advantage to weight loss of a diet that's lower in carbohydrate or higher in carbohydrate or fat or protein or whatever. And I believe that epidemiologic studies are consistent with benefit for cardiovascular disease and diabetes. So I'm really not going to discuss carbohydrate amount here. I'm going to discuss glycemic index. Okay, so I'm going to talk about risk factors for cardiovascular disease, for diabetes, weight loss or maintenance, and predicting type 2 diabetes. So the reason that I'm here is that I led the study, the OmniCarb study that was published last December in JAMA. And this is the fourth of a series of controlled feeding studies that started with the DASH study. And that DASH study, I led the study design committee of DASH and then the trial, DASH sodium. Larry Apple and I did OmniCarb, and he did as well this with me. So here are the researchers in OmniCarb. So in the Boston Center, these are the key individuals who participated. The Data Coordinating Center was at the Channing Lab at the Brigham. Vincent Carey, biostatistician, was the director. The Baltimore Center, Larry Apple, was the PI and co-chair with Pete Miller and Cheryl Anderson. And when we started the study, I knew we needed David Ludwig because we really wanted an expert. It's a tricky field, as you all would agree. We needed a true expert in this, and David was with us from the very beginning and participated in all of the phone calls and meetings about trial design and so forth, but preferred the role as consultant. Now, we started thinking about this, and partly because of David's early study where he suggested that low GI diets may improve blood lipids. And this is early. This is not a systematic review and meta-analysis. It's a group of much of the literature, shall we say, as of the publication date. And it suggested that lowering GI, lower triglyceride, lower LDL cholesterol, and improve the cholesterol to HDL ratio. So the design of OmniCarb was a controlled feeding study. So all the diets were totally composed, meals were composed, given to the research participants. It was a randomized crossover design with 2-week washout periods. The duration was 5 weeks of each period. And the OmniCarb trial had in the overall aim to address an often asked question, asked to those of us who did the DASH study: does the glycemic index of carbohydrate modulate the effects on traditional cardiovascular disease risk factors and on insulin sensitivity and glucose levels? Now, this question was put to me and other colleagues in the DASH study from the very time that DASH was published. Because DASH did not use glycemic index at all as any kind of criteria for selecting the foods in the DASH study. It just wasn't a part of it. So some were high, some were low, whatever. So this was a question at some point we wanted to try to address. And here was our hypothesis. I quote it right from the paper. So you see which side I'm on. I was on. I am on. Well, we hypothesized, you tell me. We hypothesized that a low compared with a high glycemic index, especially of a high carbohydrate diet, would cause modest, though potentially important improvements in insulin sensitivity and CVD risk factors. Recently, someone asked me, well, did you try to disprove glycemic index with your study? Is that what the idea was? Well, this was the idea. You never would try to mount a big study like this and devote a percentage of one's career for years to just try to disprove something. I mean, it's not my style or the Larry Apple style. We thought our intention was to find something that would incrementally improve what we had already discovered about the DASH diet. Okay, so there are 4 diets fed in a crossover design, 5 weeks duration. So 2 of them were high carb, and one had a GI of 66, the other had a GI of 41. It's a very big difference here. And then 2 were low carb, and you see one was high GI, one was low GI, and there was a very big difference. Okay, fiber and saturated fat was similar across the 4 diets. So, of course, right away, what David Ludwig told us is it's going to be a little difficult to maintain fiber the same in these 2 diets. Okay, he's right off. So what he recommended and what we used was wheat bran for part of the difference, not the whole difference in fiber, but part of the difference. I just make that clear, that some of the difference between the high and the low GI diet in fiber was made up by foods, and some was made up by wheat bran. Now, in the low-carb diet, there was much less of a problem with that. Okay. Complete diets were given to participants, and body weight was kept constant. Well, we kept body weight constant because we think that weight loss is a separate problem clinically and biologically than what we're looking at here. So that's why we did that. The participant characteristics, there were 163 in the 2 centers. About half were women, half were African American. This is by study design, so we'd have separate power here to look at effects in blacks. Age 53, average BMI was obese, 32. Metabolic syndrome in blacks only 13%. That's because metabolic syndrome isn't well suited for any kind of an indicator in African Americans. African Americans have low triglyceride and high HDL compared to other ethnic groups. So 2 of the criteria for metabolic syndrome are triglycerides and HDL. So that does not capture risk well in African Americans who have a high risk of cardiovascular disease. So this is just not really, I'm just mentioning this, that it's not really an important number. Now in whites, it's 31% in this group. And that's a little more substantial. So the results, well, one of our endpoints is systolic blood pressure. We had 5 primary outcomes, and lowering glycemic index had no effect. So here's how I've set up these tables. So this is the between diet difference, okay? So this would be replacing high with low GI foods. So this is low GI in a high carb diet and low GI in a low carb diet. So varying GI had no effect on systolic blood pressure nor on diastolic blood pressure. On the other hand, replacing high with low carb foods had a slight effect in reducing systolic and diastolic blood pressure. It did for diastolic, but it's very small. It's consistent with what we found in the OmniCarb study. Okay, now to our surprise, we found that lowering GI increases LDL cholesterol on the high carb, but not the low carb diet. So, okay, this is replacing high with low glycemic index foods. This is in the high carb diet. LDL cholesterol went up by a meaningful amount, about 7%. Now, lowering GI did not do that to LDL cholesterol in the low carb diet, okay? So constructing these diets based on the available food tables, based on, actually I didn't say this, but we sent our breads to Tom Walliver for testing because we really weren't sure what the GI value was, so we had that varied. Thanks very much, Tom, for helping us on that. And the breads, and we used those breads as an important component of varying GI. Anyway, I don't have any idea why the lower GI, high-carb diet increased LDL cholesterol. But there are many nutrients that change with low GI compared to high GI, foods, nutrients, and there may be some things about these foods we don't entirely understand. But I put in our data supplement, published with the JAMA article, complete menus for basically all the complete menus we used for this study, specifically to facilitate anyone's desire to study it and maybe teach us something that or form a hypothesis for testing that might explain this. But apolipoprotein B went up. It's not a fluke finding. I mean, believe me, I ran the lab and we looked at everything, every possible reason. It's not a fluke. ApoB went up, so LDL ApoB went up. So this is real. Non-HDL cholesterol went up, so forth. Okay, so we found that lowering GI did reduce triglyceride by a very small amount, about 5%, kind of at the borderline of significance. Lowering carb reduced triglyceride much more, 20 to 25%. And it was the same if the carb was high GI or low GI. Reducing carb reduced triglyceride by 20, 25%. It reduced apolipoprotein C3, reduced VLDL cholesterol and triglyceride, reduced VLDL ApoB, everything you would expect. Okay, so now let me move to the insulin sensitivity outcomes. So this is the oral glucose tolerance test after an overnight fast. To make it clear, you realize this is after an overnight fast. All right, and these are the glucose excursions on the 4 diets. So it looks, first of all, it looks pretty similar, doesn't it? Doesn't look like there's really much difference. We also, of course, did this for the insulin excursion, measured the area under the curves, used the Matsuda and DeFranzo formula, and then computed an insulin sensitivity measure. Okay, so what we found, to, again, not in agreement with what our hypothesis was, is that lowering GI reduces insulin sensitivity on the high carb but not the low carb diet. Okay, so this is replacing high with low glycemic index foods. This is in the high carb diet, reduced insulin sensitivity, no effect. This effect did not occur in the low carb diet. Okay, so I'm going to talk about this a little later, but now I'd like to move to what we originally called was a process measure, was the blood glucose levels during study meals. So we fed 3 meals. These are the meals that they were eating during the four diets. So the blue line, the top, is the high carb, high GI diet. And this one at the bottom, this sort of yellowish curve, is the low carb, low GI diet. So anyway, what you can see is after breakfast, after lunch, and after dinner, the glucose went up the most after a high carb, high GI diet. It certainly did. And that it progressively decreased. The increase, well, the postprandial hyperglycemia was less on the lower GI or lower carb diets. One point I'd like to make here, before I show you the actual numbers, is that this is 12 hours of daytime. This is not the other 12 hours. Okay? What happened during the other 12 hours? Well, I don't know. So I'm opening areas for future research, for anyone who's interested, wants to try to sort this kind of thing out. So these are the numbers. This is incremental area under the curve. And we debated whether we should use IAUC, but in a lot of debate with David, for example, Ludwig, we thought this was the best. So okay, so this is in reference, these differences are compared to the high carb, high GI diet. So on the high carb, low GI diet, 12-hour glucose AUC decreased, and the p-value was significant. On the low carb, high GI went down a little bit more, and the low-carb, low GI, it didn't produce any further reductions. These are the glycemic loads, 215, 131, about the same, 140, and 85. So how do we interpret this exactly? Well, this is what my thinking is here, that blood glucose changes in response to glycemic load in a higher range, okay, up in this range, but not in the lower range. And I'm going to discuss this in a few minutes, why I'm making such a comment. That's actually what the data say, but why this makes some sense. So now let's look at 12-hour insulin response to the 3 meals. Okay, so here really we see the biggest drop on the low-carb, low GI diet when the load is 85. We really didn't see much of a change in insulin going from high-carb, high GI to high-carb, low GI. So what's my thought on this? Well, insulin may then respond to the glycemic load to maintain blood glucose effective at low but not high glycemic loads. And that at a high glycemic load here, insulin doesn't increase enough to maintain normal blood glucose. See, that's how I would interpret these kind of results. So it's subtle, and actually what Professor Cardy said earlier about, in the earlier discussion, I think it's very relevant here to try to understand, maybe do a more detailed physiological study to try to understand these differences that you see. So how about the pre-diabetic participants? Been asked a lot about this, so this is not yet published. These are fasting glucoses over 100, about 50 of them. So the effect of low GI on fasting glucose, it increases fasting glucose on the high carb and the low carb diet, possibly increases fasting insulin, doesn't have effect on the low carb diet. The insulin sensitivity, decreased insulin sensitivity. The same thing as the overall results. So, and there was no different effects, is what I should say, in the normal glycemia participants. So these people really had the same effect as the total group. Now, this also is not published. Pete Miller at Johns Hopkins is doing this. So this is glycated albumin and fructosamine. And okay, you can see, you can look at either one because they show the same thing. So really, this is change in glycemic index, did not affect glycated albumin. Reducing carb, the trend was to reduce glycated albumin. And both factors seem to have the same effect as reducing carb. So despite reduction in the 12-hour glucose AUC, low glycemic index did not lower glycation. So lowering carb tended to lower glycated albumin and fructosamine. So again, some of this is what you'd predict and some may not be, but I think it's also worth a walk to the literature to see. Now, I gave a similar talk to the American Diabetes Association yesterday, and someone came up from the Academy of Nutrition and Dietetics, said they did a systematic review on the effect of glycemic index on hemoglobin A1C, and found the data did not support an effect of glycemic index on hemoglobin A1C. So I said, well, it's interesting. They said they published it. I'm just unaware of it. I don't know if anyone else is, but it might be interesting in the discussion to take a look at that. Okay, so summarizing OmniCarb, there is no benefit from lowering glycemic index on blood pressure and lipid risk factors. Paradoxical finding, low GI may decrease insulin sensitivity, increase fasting glucose, and increased LDL cholesterol. Now the nutritional, like why that happened, and the clinical application of it isn't clear, but I think needs to be taken quite seriously and looked into. And in subgroups, no suggestion of benefit in prediabetes, and we published also that there was no benefit and no difference in effect in the metabolic syndrome or obesity in that paper. So when you come across a result that goes against your hypothesis, you begin quickly to say, well, what's the literature say? Is this an outlier or not? So I looked into clinical trial literature in great detail. and I'll summarize it as such. In fact, the clinical trial literature has progressed very far since we planned the study. So here's a meta-analysis, 28 trials. It showed essentially no effect of lowering glycemic index on LDL cholesterol, HDL cholesterol, and triglyceride. And there was a small effect on LDL cholesterol in studies that increased fiber, but when they controlled for fiber, they really didn't see any significant effects. So that's consistent with OmniCarb. And now about duration. Well, the study was 5 weeks in duration for each dietary period. That was very carefully vetted by the National Institute of Health study sections and all that. It worked. 5 weeks is perfectly fine for looking at the effects of many things, like sodium on blood pressure, potassium, dietary fats and fatty acids, on lipid risk factors, and so forth. So why shouldn't it be for this? Well, I don't know. Could be different. Maybe not. So let's look at what the literature says. So with longer duration, if anything, there's less effect on LDL cholesterol. And there's no effect anyway on HDL cholesterol or triglyceride. Okay, now how about the swing shackles meta-analysis of trials at least 6 months duration? Well, there's a lack of favorable effects. And this is hemoglobin A1C, 4 studies, no effect. LDL cholesterol, no effect. HDL, none. Triglyceride, none. So long duration doesn't give you, doesn't sort of unmask or unleash effects of low GI on hemoglobin A1C or lipid risk factors. All right, now how about weight loss? A couple slides on that. Well, this is the DIOGENES study. I think it's an ingenious design. They induced weight loss and then did a randomization to 4 different diets and looked at weight regain. And the weight regain was the most on low protein, high GI. See, they hypothesized that that would be true. It was least on high protein, low GI. So it's sort of, the results were exactly as they had hypothesized. Okay, but weight loss, very tricky thing. You know, I did a 2-year study, comparative study, pounds lost. Very tricky business. Short-term results don't always translate to long-term. So this is their 1-year results. So yes, the protein result was substantiated at 1 year. Low protein, more weight gain. But the GI didn't work that way at all. And I just wonder why you don't see this slide much in presentations or in citations. So look, I mean, this is the real data. It's, you know, should be taken into account. The authors fought for it to be published, did get published, so do they stand behind it or not? It's the opposite to what they hypothesized. Okay, back to the meta-analysis of low GI GL trials of at least 6 months duration in non-diabetics, lack of favorable effects on body weight, waist circumference, or fat-free mass. This is body weight, 10 studies, no advantage, waist circumference, no advantage, fat-free mass decreased significantly on the low GI diet. That's not good, right? Okay. All right, so now let's sum up here. Interpretive points. Many low GI foods are high in fiber, unsaturated fat, micronutrients, other beneficial nutrients. So sorting out what in a food can be attributed to low GI or other things, I think need to be looked at. Surrogate or mechanistic markers for diabetes are not as secure as for CVD. We use fasting glucose, we should use hemoglobin A1C, we should use 12-hour meal testing. There are a lot of things. How about hepatic glucose production or first phase insulin secretion? There are a lot of potential mediators in this field that I think need to be more carefully looked at in terms of glycemic index. Okay, I've said this, and I know we're running short on time. And I just would like to end with 2 slides from epidemiology, and I'll just quote the conclusion on this BMJ article, which I think has a bit of an object lesson for us. Greater consumption of specific whole fruits, particularly blueberries, grapes, and apples, was significantly associated with a lower risk of type 2 diabetes, whereas greater consumption of fruit juice is associated with a higher risk. And I emphasize in red here, in addition, the associations of individual fruits are not determined by their glycemic index or glycemic load values. So what? glycemic index doesn't apply to the category of fruits. How do we, how do we interpret that? And how do we interpret this? This is a powerful effect in epidemiology for glycemic index predicting type 2 diabetes in 3 large cohorts of US men and women. And in fact, this was substantiated by a systematic review and meta-analysis in the same article of all studies that are available. It's very powerful, and I think on the positive side of glycemic index's relevance, we need to keep this in mind also. I'm saying there's still a lot to sort out scientifically about the health effects of glycemic index. Thank you.
Very nice presentation, as always, Frank. Weren't you a bit surprised at the DIOGENES study? I mean, they show for the first, what is it, major study with 24 weeks or whatever it was, there they show the glycemic index weight reduction effect as being positive for a low glycemic index diet. And then it flips on the long-term one. But if you look at the first 24 weeks of your long-term slide, it's flipped there already. So somehow there's a disconnect between the first 24 weeks of the 2 publications, which I find strange. I haven't asked Arnie what the reason was. But
Yeah, I find that strange also. I noticed that. I don't know. I agree with you. It's not a pure duration effect. It's it's the 2 centers that participated in the long-term extension.
Jenny, that's all right.
Jordi Salas from Rovira Virgili University. In your study, you have observed more benefits of reducing carbohydrates than changing the glycemic index. This can be explained. This can be explained by the amount of fat and the type of fat.
Well, sure, exactly. So you reduce carbohydrate, what goes up? I mean, in our study, fat went up and protein went up. And the fat that we used was mostly unsaturated, monos and polys.
This is in line to the Prediabetic study, probably.
Absolutely.
Jenny, did you?
In your OmniCarb study, you show clearly that when you replace some of the carbohydrate, about 10% of the energy, with some protein or with some good fats, that you see modest improvements in lots of the cardiovascular risk factor. So what that suggests to me is there's something about the carbs that is actually working against health, working against it. So what is it about the carbs that you think are actually causing the improvements when you avoid them?
Well, I mean, that's a provocative question. I'm really not so sure myself, except that when we reduce carbohydrate, and in most studies, when carb goes down, fat goes up. So I could say, well, maybe it's actually an effect generically of dietary fat.
But you got it with protein too.
Protein goes up a little bit too. Yeah, no, I mean, we saw...
When you replace the calories with protein, you got an improvement too.
Yes, no, that is true. So no, I agree with you. It looks like there's something adverse about carbohydrate in these risk factors. So maybe what you want to do is figure out a way to make that take that away.
Right. So if I may, Frank, obviously it's a tremendous amount of work. I have some comments, and then I would like to ask you questions and see what lesson you learned. Looking at this, obviously, one, I think, most straightforward interpretation of the inconsistent findings between your trial and some of the observational epidemiology cohort, which, as you indicated, has been fairly consistent now with not only the Harvard cohort, but multiple prospective cohort studies that have shown that, in fact, Giraffe and I did a meta-analysis, did, however, identify some heterogeneity across the sex. For example,
Across the which?
across the sexes. The man, not your
Across the which?
sexes.
Oh, sexes.
And it's most likely according to sex.
Well, maybe I should take what I can get.
So that's pretty consistent with the findings between in terms of the heterogeneity. So I wonder whether or not there is essentially you are really looking at oranges and apples, meaning that the kind of diet that you introduce in your trial is completely different from the observational study. The participant consume that kind of diet. Now, the reason why I said that is that in your study you indicated it's in the context of DASH diet. Most likely, the good fats and the good kind of diet that you have already well designed. And then you have a weighted average of the quality of carbohydrate. So let me tell you how did you calculate the overall dietary glycemic index in your diet. It is essentially a weighted average. A weighted average meaning the individual glycemic index of the food times the carbohydrate content and then further divided by the total carbohydrate consumed. So it is a distorted version of glycemic index. It's not the glycemic index from the food itself, but more like for your overall diet that is constrained by the DASH diet that you define. So it is almost not possible to see any differences between those. It basically mixes up the diet. Now that said, you do see LDL. Your LDL finding among all the biomarkers you look at, do you think it is not possible to jump up with this multiple comparison, that one thing that just ought show up with the multiple comparison that you look at?
Well, your last point is the easiest to answer. There was a Bonferroni correction times 5. Okay? Now, your other questions, that's more complicated. So we computed the glycemic index. Well, all right, let's back up a little bit. So yes, our research question was to look at varying glycemic index in the context of a healthy dietary pattern defined by the DASH study or basically the OmniCarb study. That is true. Okay, so how dependent were the results we obtained on that particular dietary comparison? I think that's really what you're asking for. And that's really where the meta-analysis in the literature says that we can generalize the results, because if you saw the meta-analyses that I showed you of the clinical trials, they were uniformly null for the cardiovascular risk factors as well as hemoglobin A1C in the non-diabetics. So there it was. That's how we could generalize to other diets.
I think this is a very interesting study, and there are some things which I've had fortune to discover through doing meta-analyses over the past 10 years or so. One is that it's really quite hard to find effects sometimes in diabetics if they don't have a very large dysregulation of blood glucose. I'm speaking of dysregulation of blood glucose now. I'm not talking about dysregulatory mechanisms like the change in insulin sensitivity. And that is that if you ignore a meta-analysis, the meta-analysis might show that it's a very poor result or a small effect. But when you begin to look at the degree of dysregulation, you can find that there is indeed a relationship with the degree of dysregulation. So that's one point. The next is, if you're doing a meta-analysis, you find that control of the studies is very difficult. And you can get studies on glycemic index and glycemic load, where some of them will show the opposite effect of others. Now, if you then turn to meta-analysis and control for the degree of dysregulation, and plot out the differences in, say, glycemic index and glycemic load as another factor, then you begin to see in all those studies that there is a relationship between either glycemic index and glycemic load. So I think your studies will probably fit into some point along these sort of meta-analyses. And I think it's worthwhile. I think it's worthwhile pursuing the work and looking at the confounders that there can be, or the other explanatory variables in the study.
Oh yes, I agree. It sounds like the Livesey meta-analyses that were published, that were so important. I studied them very intensively. I completely agree with your comments.
My question relates mostly to whether there is any residual effect of the washout period, and what is the bad composition that you gave during this period of time.
Oh yes, thanks for that question. Well, in OmniCarb, actually in all of the studies we've done, the washout period was effectively a break from the rigid dietary protocol in which they would just eat their own favorite diet, whatever they chose. We did not regulate the content of what they ate during the 2-week washout.